Hi, so today we'll be talking about synaptic plasticity, which is the increase of the synaptic strength inside of the membrane. So first we have what causes CA2 plus. What causes that is it to be triggered and to start to bind when the neurotransmitters are released and the potential starts the process of exocytosis. That's the first sign of CA2 being released from the membrane. Then we jumped into the paired pulse facilitation, which starts with the prenaptic potentials. It is the increase of impulses to the action potential that excites the EPSPs. And then we jump over to the paired pulse depression, which is the form of two short-term plasticities to inhibit a stimuli and make it elevated. And it decreases the rate and increases the amplitude of the cell. So, the whole process of synaptic plasticity starts with hypotation, and that is when there's a response in the cell that is repeated, and it causes less of a response because of the repeated stimulus. And the sense of the light touch causes withdrawal of the gill, and the gill becomes weaker, and it is repeated of the stimuli, which causes sensation. So pretty much sensation is the response that is created by the stimulus to a variety of stimuluses. This happens with the pairing of a siphon stimulus to cause EPSPs in the grill cell, in the grill motor. The repeated motion causes synaptic depression by reducing EPSPs, but with the release of neurotransmitters, increases the EPSPs in the motor neuron to excite grill muscles. So then we move to the long-term potentiation, which is the process which produces a long-lasting increase in synaptic strength, and it generates the EPSPs in the postsynaptic cell. That's where the CA1 is located. So if there is a stimulation, then the size of the EPSP stay the same. It's a response that is sent to the axons that can cause an increase in the EPSP amplitude. So in this case, there are two stimuli, which is the CA1 and then the CA3. It's a thick band formed from the dendrites of the CA1 and receives synaptic form with the scapher collaterals. So it goes to the CA3 region. And pathway 1 is the response of the CA1 from a single stimuli of synaptic pathways, while pathway 2, the EPS size didn't reach high frequency, so it stays unchanged and consistent in picture C at the bottom. Response in the pathway causes pathway 1 to enhance the EPSPs and pathway 2 remains consistent. So then we talk about the Hebbian synapse. It's a connection of presynaptic correlates with the postsynaptic firing. The stages include cooperativity, associativity, and specificity. And this is compared to the LTP in response to this is what triggers the firing inside of the cell. And they both relate in that aspect because in the LTP, there needs to be a sense of firing that takes place. And the response that is sent because of the EPSPs inside of the cell. So as I stated before, so two of the main types, the first one is specificity. It is when one side of the synapses can be active and the inactive synapses increases effects for impulse for information storage. And then associativity, which is letter B, is when a weak stimuli combines with a strong stimuli and causes the LTP, which is the long-term potentiation. Then we move to the NMDA, which allows the flow of CA2 through the cell, but it is blocked by the Mg2 plus, and it opens when glutamate is bound to the receptors and causes depolarization for the release of the Mg2. So once the glutamate is released in the NMDA channels, the mDNA channels open, and the process of depolarization starts to happen. The Ca2 ions enter the cell for postsynaptic activation. They recycle the endosomes for the AMPA receptors, and an increase in spine sensitivity to glutamate causes the long-term potentiation. So then we have the late stage of the LTPs, and that's caused by the protein kinase A, and it activates the CREB and stimulates other protein, causing the long-term changes in the pKa. Okay, so now we're looking at the long-term depression mechanisms and depression. Okay, that's caused from the slow rise in the CA2, and the LTD happens from the result of the activation of the phosphates. They happen from the loss of synaptic AMPA receptors in the postsynaptic and decreases the release of the glutamate. So LTD does occur at the synapse between Schaefer collaterals and CA1 pyramidals. Cell is hippocampus, and it is starting in the hippocampus and occurs when the Schaefer collaterals are stimulated at a low rate, which slows down the EPSPs inside of the cell. So then we have the silent synapse, and that is found inside the hippocampus, and it is a silent synapse because of the voltage-dependent blockage of the NDA receptors by the Mg2 that is stored inside the cell. It turns into functional synapse when the maturation of glutamatrix synapse. So when the glutamate matures inside of the cell, that's what causes the functional synapse. And then once the process is done, it returns to resting membrane potential stage. And that comes after hyperpolarization from the potassium leak channels inside of the cell. Thank you for this presentation. I appreciate you listening. Have a good day.